This video is on section 2-6 on proving angles are congruent. By the end of this video, you should be able to explain what a proof is and the format of a proof, explain the vertical angles theorem, the congruent supplements theorem, and the congruent complements theorem. You should also be able to prove a few theorems about angles. And this video covers geometry standards G.1.1 and G.6.2. I mentioned this in the last video, but let me reemphasize that in geometry, we will take certain postulates and definitions and properties as true. Okay, we'll accept them as fact, and then we will use deductive reasoning to prove other statements as true. Okay, these other statements we will call theorems, and a theorem is simply a conjecture that has been proven true by using deductive reasoning. So we will use these postulates, definitions, properties. We will use other theorems that we've proved, and using deductive reasoning to prove new statements. Okay, the format that we use, most often we'll use a two-column proof. A two-column proof has two columns. The left column has the statements, and the right column has the reasons. Okay, the reasons for those statements. We will also always start with a given statement. So we're given some fact, and that will always be our first statement, is our given. Okay, and the reason for that statement will be given. Okay, and our goal is to use some deductive reasoning and kind of work our way logically down until we reach the statement that we're trying to prove is written up here at the very top, and that will always be our last statement. Okay. Keep in mind that every statement that we make, the reasons are over here on the right-hand column. Okay, so this is a really nice format to use in proving something. You make logical steps, giving reasons and justifications for each step, and that'll prove a statement to be true. A very similar format is a paragraph proof. Again, we have the given, and we have the prove statement. Except our proof does not have two columns, it's a paragraph. Okay, we will still start off with the given, and we'll make logical steps down until we reach our prove statement. But instead of having two columns, we have it in a paragraph where it's written out in words. But keep in mind that you're justifying each step as you're writing out your proof. Okay, so let's look at our first theorem. It's the vertical angles theorem. Okay. Over here we have two intersecting lines, and you should recognize these as forming some vertical angles. Okay, angles 1 and 3 are vertical angles, and angles 2 and 4 are vertical angles. Now the theorem states that vertical angles are congruent. So angles 1 and 3 are congruent, and angles 2 and 4 are congruent. Okay, and in order to write a proof, we first need to think about why should this be true. Now I know that you want to say, well, they look like it, or they're two straight lines, and so it makes sense that they would be have equal measures or be congruent. And although I agree with you that it does look like it, we can't base a proof on, well, it looks like it should be. Okay, we need to have another reason why, and we will prove specifically that angles 1 and 3 are congruent, and we will use angle 2. We'll use angle 2 in our proof. So looking at angles 1, 2, and 3, we may notice that angles 1 and 2 are a linear pair, and so they're supplementary. And angles 2 and 3 are a linear pair, so they're supplementary. Okay, and so we'll kind of head in that direction, and we'll see if we get to where we need to be. Like I mentioned before, the format of the proof, we have a given statement. We're given that angles 1 and 3 are vertical angles, and our goal is to prove that angles 1 and 3 are congruent. Okay, we will always, our first statement is always the given statement, and the reason for that is it's given. Okay, I mentioned that we'll use angle 2, and we'll notice that angles 1 and 2 are supplementary, and angles 2 and 3 are supplementary. Okay, so The next logical step from that statement is, what does it mean to be supplementary? Well, angles 1 and 2 add to be 180, and angles 2 and 3 add to be 180. Okay? And the reason for that is the sum of the measures of supplementary angles is 180, or by the definition of supplementary angles. Okay, so now that we have equations, we can use everything that we know about solving equations to help us. Okay? And we will notice that these two equations both equal 180, which means that the measure of angle 1 plus the measure of angle 2 would be equal to the measure of angle 2 plus the measure of angle 3, because they both equal 180 degrees. Okay, so we're going to put these two parts equal to each other, and the reason given here is the transitive property of equality. It could seem more like substitution to you, but that's, you have a reason for it. And then you'll notice that the measure of angle 2 is in both sides of the equation. Okay, and the measure of angle 2 is just a number, and so I can use the subtraction property of equality to subtract what the measure of angle 2 is, and I'm left with the measure of angle 1 is equal to the measure of angle 3, and that's what it means for angles to be congruent, is that the measures are equal. Okay, so here's our proof of the vertical angles theorem. We start with a given, we work down to a proof statement, we make some logical steps and justify each statement. Okay, I hope that makes sense. All right, so let's practice using the vertical angles theorem. Now, again, the idea is that the vertical angles are congruent. So this is equal to this. So 5x is equal to 150. Well, right now x is being multiplied by 5, so the opposite of multiplying is dividing by 5. And x is equal to 30. Okay, and this one, a little more complicated, but keep in mind that these are still vertical angles, and so they are congruent by the vertical angles theorem. So 7x minus 27 is equal to 4x plus 12. The way I'll solve this is by subtracting 4x from both sides. 3x minus 27 is equal to 12. I will add 27 to both sides. 3x is equal to 39. And then I'll divide both sides by 3, and x is equal to 13. Okay, so the vertical angles theorem is that vertical angles are congruent, and we can use that to find what the measure of angles are, or find the value of x. All right, here is another theorem, the Congruent Supplements Theorem. The theorem is, if two angles are supplements of the same angle, or if congruent angles, then those two angles are congruent. Okay, in the picture, let me show you that if angles 1 and 3 are supplements, okay, and angles 2 and 3 are supplements, then it must be true that angles 1 and 2 must be congruent. Okay, so before we look at this proof, we'll ask ourselves the very important question of, why should this be true? Well, if angles 1 and 3 are supplements, what does that mean? Well, it means that their measures add to be 180 degrees. If angles 2 and 3 are supplements, that means that their measures also add to be 180 degrees. And if you're noticing that we could do a similar thing in this proof that we did in our last proof, you're right. Okay, so we'll kind of head in that direction and see if we get to where we need to go. Again, we always start with our given. We want to work down to the prove statement. And this time we'll use a paragraph proof. And so I'll just show you. Start with the given. Angles 1 and 3 are supplementary because it is given. Okay, so the measure of angle 1 plus the measure of angle 3 is 180. That's what it means to be supplementary. Um, angle 2 and 3 are supplementary because it is given. So the measure of angle 2 plus the measure of angle 3 is 180 by the same definition. Okay, so by the transitive property of equality, the measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 2 plus the measure of angle 3. Now, we're doing the same thing we did before, the fact that both of these equations equal 180 degrees. So we're setting these two parts equal to each other. And we get this long formula down here. And notice that just like before, there's a part that shows up on both sides of the equation. This time it's the measure of angle 3. So we subtract the measure of angle 3 from both sides of the equation, and we're left with the equation the measure of angle 1 is equal to the measure of angle 2. And angles with the same measure are congruent, so angle 1 is congruent to angle 2. Okay, that's the proof. Now we started with the given, we worked down to the proof statement, we made logical steps, and there's a justification for each step. Okay, so you can think about which, if you preferred the two-column proof or the paragraph proof, whichever one you want to use in homework and tests, it's fine with me. Okay, here's a few more theorems that these expose you to. Theorem 2-3 is the Congruent Complements Theorem. Very similar to the Congruent Supplements Theorem, except this time we have complements and not supplements. Okay, and if we wrote the proof, it would be very similar, except things would be equal to 90, not 180. If two angles are complements of the same angle, then the two angles are congruent. Okay, Theorem 2-4 is that all right angles are congruent. Okay, which makes sense. Their measures are 90 degrees, and so they'd be congruent. Theorem 2-5 is that if two angles are congruent and supplementary, then each is a right angle. Okay, what that means is if you have two angles that are congruent to each other and they add to be 180 degrees, it makes sense that both angles would have to be 90 degrees. Okay, and we could write proofs for each of these, but we'll kind of move on and look at some other theorems. Okay, let me point out something pretty important over here. The theorems with names are more important than the theorems without names. Okay, not that the other theorems are less important. It's just that the theorems that have names will come up multiple times, and that's why they're given names. And so focus on the theorems that have names. All right, prove that the value of x is 52. Justify each step. Okay. Now we're not given a given statement in this theorem, but we can find one from the picture that we're given. Okay. So our very first statement will be, well, if you look at the picture, all we really have to work with is that we have some vertical angles. Okay. And by the Vertical Angles Theorem, these two angles are congruent. So 4x minus 101 is equal to 2x plus 3. And the reason is the Vertical Angles Theorem. Okay, what would the next logical step be? Well, we're going to solve this, and so this is kind of like what we did in the last section. To solve this equation, I would subtract 2x from both sides. Okay, so I'm going to use the subtraction property of equality. And subtract 2x from both sides. Okay. And I would get 2x minus 101 is equal to 3. Okay, and that's statement 2. Ooh, I should number these. Okay, my third statement is I would add 101 to both sides. And now we get 2x is equal to 104. And that's by the addition property of equality. And then I would divide both sides by 2. And I get x is equal to 52 by the division property of equality. Okay, and we're done. Now, I had more lines here, and that's fine because we don't know how long our proof will be when we start, but we just start with what we're given and we kind of work our way down, making logical steps until we get to our proof statement. Here's another one. Given that Wx is equal to yz, so this part is equal to this part, we want to prove that wy is equal to xz. Okay, we will always start with our given. Wx is equal to yz, and the reason is that's given. We will always start with that as our first statement. Now, let's think about why should this be true? Well, the only thing we could really use is looking at xy, because that's in both intervals. Okay, so let's see here. I can add the same thing to both sides of my equation by the by the angle addition postulate. Sorry, by the addition property of equality. So I'm going to add xy to both sides of the equation. Okay. Now, if you look at wx plus xy, that is equal to wx plus xy is this segment right here. So that's equal to wy. And yz plus xy is this segment. So that's equal to xz. And I'll say the reason for that is the segment addition postulate. Okay, we covered that kind of towards the beginning of chapter 1, but it's a useful postulate for us. And we're done. 3 steps, not too bad. So we start with our given, work down to the prove, make some logical steps. Okay, here's some fill in the blanks as questions like this will show up in your homework. The first statement is always the given. Angle A is congruent to angle BDA is our given. And the next reason is the vertical angles theorem. Sorry, vertical angles are congruent, and so we'll be using some using the congruent angles that we have in our picture. Angle BDA is congruent to angle CDE. Those are vertical angles. Okay. The next statement is that angle A is congruent to angle CDE. Well, if you look up here at the first 2 statements, I have that angle A is congruent to angle BDA, and angle BDA is congruent to angle CDE. So it looks like we're using the transitive property of congruence. Okay, the definition of congruence is what we're using, and the definition of congruence is that angles that are congruent have the same measure. So it'd be the measure of angle A is equal to the measure of angle CDE. Okay, so let's see here. The next step is, it looks like we're plugging in what angle A and what angle CDE are equal to. So we must be using the substitution property. Let's see here. So using the subtraction property, we must be subtracting, I'd probably subtract 11x from both sides. And we get 20 is equal to x plus 15. And then the next step and reason are both blank, but if I solve this equation to prove that x is equal to 5, I would probably subtract 15 from both sides. And I would get x is equal to x equal to 5 by the subtraction property. Okay. So I know that it's in some ways easier because you don't have to find all the statements and all the reasons, but you might get lost in trying to figure out how to make the steps. So think about what reasons you have, what statements you have, and try to figure out and fill the missing holes. Okay, this video was about proving angles to be congruent. We are now just starting to work with proofs. We'll do a lot more of proof in the next chapter and in the next several chapters. Proofs are challenging for a lot of students at the very beginning. And so if this section seems a little challenging, just stick with it. I will be able to help you, and Ms. Swanlin will be able to help you in class. But this video is about explaining what proof is, exposing you to a couple of theorems, and proving some theorems about angles.